Alrighty, so today, now that we know what a term is, we're going to be able to identify like terms. We're going to be doing problem 2, 3, and all of these in problem 4. Problem 1 you should have done first. So if you haven't done problem 1 yet, see if you can do number 1.
For number 2, it says list all the terms in the expression below. So remember, a term is going to be each part of this problem that's separated by a subtraction or an addition problem. So our first term that we have is 8c. Our second term that we have is negative 5. Remember that whenever we've got a minus in front of a term, we're going to keep that minus as a negative. If it helps you to see it better, whenever we've got subtraction in these, we can do our keep change to have those negatives with the numbers. So 8c plus negative 5 is the same as 8c minus 5. So that's how we get this negative down here. So negative 5 is our next one. The 4c squared is going to be positive because it has a plus sign. Plus is positive. So 4c squared. Also remember this little 2, an exponent of 2, a power of 2, we call that squared. A power of 3 we call cubed. So 2 is square, 3 is cubed. Our last term is 2b. It has a plus, so it is positive 2b. And those are all the terms in this problem. So remember, everything in between pluses and minuses are going to be our terms. The numbers, the coefficients attached to the variables go together with it to make one term. The constants are just the number, and we keep whatever the sign is in front of it with it. So if it's a plus, it keeps it positive. If it's a minus, it stays negative. So that's how we do our terms. So once we know what the terms are, we can then identify like terms. But first, we're going to circle the coefficients in the expression below. So I want you to have 1 second. You're going to answer this question, and you're going to see if you can tell me them first. Now that you're back, let's circle the coefficients. Remember, a coefficient is the number that is attached to a variable. So our 5 is attached to the variable, 7 is attached to h, and this negative 2 is attached to the g. With the plus, we don't have to show it because 7 is already positive. With the 2 being after the minus, we need to include that minus to show that it's a negative 2. So now in number 4, we're going to give an example of a like term for each of the following. So if I have negative 50, I need to match the variable and match the power. 50 doesn't have a variable, so I need a number that doesn't have a variable. The power, we don't have any exponents, so I'm not going to have any exponents. So this could be any number, positive or negative, that doesn't have a variable attached to it. I'm going to go ahead and just say 3. Positive 3 and negative 50 are like terms. The positive and the negative does not change them being like terms. It's the variable and the power. So these are both constants, even though one's negative and one's positive, they're both still constants, so they are like terms. In 3b, I need to have a variable of b, and I need it to not have an exponent. So I'm going to do 10b. Actually, we'll make it negative 10b, because again, the positive and the negative are not what's deciding if it's like terms. It's the variable and the exponent. Negative 5a, I have a variable of a with no exponent, so I'm going to put, this time we'll just do the opposite. We'll say 5a. And then our last one, we have x squared. Whenever we have a variable by itself, when we can't see the coefficient, that means that it's 1. This is 1x squared. So when we're adding or subtracting our like terms together, when we have just the letter by itself with no coefficient, like 3 and negative 5 here, that means that it's 1. So I need an x with an exponent of 2, a power of 2, and x squared, I'll do 100x squared. So all of these now are like terms. They have the same variable and the same exponent. Remember that constants are like each other, variables are like each other, and the exponents have to match as well. So in conclusion, like terms have the same variable with the same exponent. So this is our reminder. Remember, x and x squared, they're both the same variable, but they're not the same exponent. This one doesn't have one, this one does. So they have to match both parts in order for them to be like terms, or they can be constants. That's no variable at all. So plain, regular schmegular numbers, positive or negative, are like terms. And that's how we identify like terms.